All right, class. So we're going to start a new chapter. Now we've talked about reactions, and we said when we have a reaction, we have reactants going to products, right? You have reactants, they're going to add up together, and then they're going to form products. And this is an example of a reaction: N2 gas plus H2 gas going to ammonia gas. And we said every time you get a chemical equation, what's the first thing you have to do? The first thing you have to do, don't even think about it, you have to balance the equation. Now let's balance this equation together. I have 2 nitrogen. I'm going to add 2 over here. So I have 2 nitrogen. It matches that. I have 2 nitrogen over there. And then now I have 6 hydrogen. So I'm going to add a 3 over here. So then I have a 6 hydrogen, and this is going to balance out. Okay, so I have a balanced equation. You're good so far? Now, how did you balance it? You balance this equation by adding coefficient, right? So you balance this equation by adding coefficients. Now, what do coefficients mean? What do coefficients mean? Do coefficients mean grams? Does that mean I have 1 grams of N2, 3 grams of H2 forming 2 grams of ammonia? What do coefficient mean? Do they mean grams? What do they mean? So I need you to really remember this for me. What coefficients mean mole ratio. So what do coefficients mean? Coefficients mean mole ratio. And later on we're going to come back to this, but I need you to really remember that. So let's say it together, even though I can't hear you. What does coefficient mean? Coefficients mean mole ratio. Coefficients are the mole ratio. Coefficients are the mole ratio. Now, you might ask me, hold on a second. Before I repeat, coefficients are the mole ratio. What the heck is a mole, right? So that's what we're going to talk about today. What is a mole? What is a mole? Okay. Now, tell me this. When you go to buy eggs, how do you buy eggs? How do you buy eggs? You usually buy eggs by the dozen, right? Okay. So when you go and you buy 1 dozen eggs, how many eggs is that? You go and say, okay, I want to buy 1 dozen eggs. How many eggs is that? That is 12 eggs. If you go and buy 2 dozen eggs, how many eggs is that? 24, right? So when we go and say, oh, I want 1 dozen eggs, that is 12 eggs. Okay. Now, what's mole? Mole is basically if you want to go and you want to buy atoms, you want to buy compounds, you buy them by the mole. Okay? Now, the same way that 1 dozen is 12 eggs, 1 dozen eggs, that means I have 12 eggs. You go, oh, give me 1 dozen eggs, which means give me 12 eggs. 1 mole is 6.02 times 10 to the 23rd atoms, molecules, or ions. I will talk about that in 1 second. So 1 mole is 6.02 times 10 to the 23rd atoms, molecules, or ions. Okay? Why is that number so big? So when I tell you go and get me 1 mole of carbon, how many carbon atoms do I mean? 6.02 times 10 to the 23rd. That is a huge number. What's up with that? Why is this number so big? This number is so big because atoms are so tiny. So we need to put a lot of them to be able to measure it. Okay, so you gotta know moles. You gotta know moles in chemistry. 1 mole is 6.02 times 10 to the 23rd atoms, molecules, or ions. Now, we have a name for this number. We call this number Avogadro's. Guess who came up with this number? Avogadro's. We call this number Avogadro's number. Unfortunately, on your iPhone calendar, it doesn't have mole day, but it exists for chemists. June 2nd or October 23rd are the 2 mole days, okay? So if you remember that, send me an email and say happy mole day. It's a legit holiday for us. So far, so good. All right, so this is mole. So 1 mole is 6.02 times 10 to the 23rd. Atoms, molecules, or ions. Now, I want to go over why all of those three are pretty much the same. Why is a mole can be atoms, molecules, or ions. So let's go over that right now. All right, what are the coefficients again? Coefficients are the mole ratio. Coefficients are the mole ratio. Now, check this out. If I say I have 1 mole of AU, okay? If I say I have 1 mole of AU, that means I have 6.02 times 10 to the 23rd atoms. Because what is AU? AU is an atom. So AU is an atom. If I say I have 1 mole of AU, that means I have 6.02 times 10 to the 23rd atoms. Because 1 mole, that would be 1 AU is an atom. You get that good so far? So AU is an atom, so it will be 6.02 times 10 to the 23rd atoms. Now, if I say I have 1 mole of AuCl3, if I say I have 1 mole of gold 3 chloride, then what do I mean? That means I have 6.02 times 10 to the 23rd what? What is gold chloride? Gold 3 chloride is a molecule. That means I have 6.02 times 10 to the 23rd molecules. Because gold, this is an atom, right? Now this is a compound, this is a molecule. Now if I say I have 1 mole of AU plus 3, what does that mean? I have 6.02 times 10 to the 23rd what? What is AU plus 3? When atoms have charges, what do we call them? We call them ions. So over here, when I said 1 mole is 6.02 times 10 to the 23rd, atoms, molecules, or ions, it depends on what I'm talking about. If I'm talking about an element, that's an atom, right? If I'm talking about a compound, those are molecules. If I'm talking about atoms that have charges, right, those are ions. We're good so far? Okay, beautiful. Now, there is a problem. There always is, right? Here's the problem. If I tell you, go and get me 1 mole of carbon, can you go and sit down and physically measure 6.02 times 10 to the 23rd carbon atoms and then come and give it to me? I hope you have better things to do, right? So it's not really possible. If I tell you go get me 2 moles of carbon, you cannot sit down and count that many carbon atoms. We can't physically measure moles. So that's the problem. We can't physically measure moles. But what could we physically measure? Mass, right? You can physically measure mass, but you cannot physically measure moles. Grams can be measured. Moles can't. We can't physically measure it. So because of that, what we're going to do over the next few lectures, we are going to learn how to convert between grams to moles to atoms and molecules. We're good so far? Okay. Again, and I wanted you to know why we're doing that. The reason that we're doing that, because we can't physically measure moles. If I tell you, go get me 1 mole of carbon, you can't sit down and count 6.02 times 10 to the 23rd. Don't try to prove me wrong. You can. You can physically measure that. So we have what we can make, grams can be measured, right? So what we're going to learn, we're going to learn to be able to convert between moles and grams and molecules and atoms. I'm going to put up a little chart. I want you to write this chart. I want you to highlight it and then circle it in red. Grams can go back and forth to moles. And moles can go back and forth to atoms, molecules, or ions. Okay? Now, to go from grams to moles or moles to grams, what you need is molecular weight or molar mass. We'll just put MW. Okay? To go from moles to atoms, molecules, ions, you already know. How do you go from moles to atoms, molecules, ion? What you need is Avogadro's number. Okay. I need you to have this in front of you for the next couple lectures as we're doing this. So, you can go back and forth between grams and moles using molar mass, using molecular weight. And you can go from moles to atoms or atoms to moles and go back and forth using Avogadro's number. We're good so far? Okay. Now, one last thing to talk about before we do some practice problem. And we're going to do an easy one today to just get it out of the way to make sure you understand the concept. Let's go over here. So, to go from grams to moles, you need molecular weight or molar masses from the periodic table. You have a periodic table in front of you? Grab a periodic table for me. Now, tell me, what is the molar mass of carbon atom? What's the molar mass? What is the molecular weight of carbon atom on a periodic table? If you look at it, you're probably going to say, you take out a periodic table and tell me what is the molar mass of carbon. Carbon has an atomic number of 6, and then the mass of carbon is 12. We've learned that before. Now, here's the thing. One thing I never told you, and you never asked me, or you couldn't ask me since this is recorded, was what is the unit of this, right? We never talked about this. So we said mass of carbon is 12, but 12 what? The unit for those molar masses on a periodic table is grams per mole. Is grams per mole. That matters, and I need you to remember that. Is grams per mole. So what does that mean? That means if I take 1 mole of carbon, if I take 6.02 times 10 to the 23rd carbon atoms, and I weigh them, how much do they weigh? 12 grams. So I need you to remember that right now, that those molar masses is for 1 mole. What is the molar mass of nitrogen? Look at periodic table. Is 14. What does that mean? If I take 6.02 times 10 to the 23rd nitrogen atoms, and if I weigh them, how much are they going to weigh? 14 grams. Okay? So again, molar masses, those molecular weights, are for 1 mole. If I take 1 mole of carbon, 6.02 times 10 to the 23rd carbon atoms, and I weigh it, I'm going to get 12 grams. Okay, I need to remember that. So the unit for a molar mass for molecular weight is 12 grams per mole. Grams per mole. Grams per mole. We're good so far? Okay. Now, I need you to have this in front of you as we're doing practice problems. Now, what I'm going to do right now, I want to do a couple of easy practice problems because I want to get the concept out and then the calculating errors that you can get out of the way. And the next lecture, we're going to do a little bit more harder questions. So here is the first question to start by to kind of make sure you get the concept down. If I buy 5 dozen eggs, okay? So if I buy 5 dozen eggs, how many eggs do I have? Again, this is not the best grammar. I'm just going to shorten things out. So if I buy 5 dozen eggs, how many eggs do I have? Now, here's how you would start this question, right? So I have 5 dozens right here, right? So I'm going to start off with 5 dozens. You agree? That's what's given to me. Now, I'm going to do a conversion here. I know that 1 dozen is 12 eggs. Okay? So I can cancel out the dozen and I end up with eggs. Okay? It will be 5 times 12 divided by 1. I will get 60 eggs. You guys follow that? Okay. That's kind of an easy problem to make sure we get the concept down. I want 5 dozen eggs. And I know 1 dozen is 12 eggs, so I end up having 60 eggs. We're good so far? Okay. Now, the next question that we're going to do, now let's do this in a chemistry term. This is in terms of grocery shopping. Now let's put it in a chemistry term. What I'm going to put right now, I have how many molecules are, how many molecules are in 2.45 moles, 2.45 moles of SO2. Okay? Now, you're always going to write down what's given to you. The only number I have is over there. I have 2.45 moles of SO2. That's what's given to me. You agree? Write down what's given to me. I don't want moles. What do I want? I want molecules. Guess what? I'm going to come down here because we talked about this. So I don't want moles. I want molecules. How do you go from moles to molecules? We said to go from moles to molecules, we need Avogadro's number, right? To go from here to here, we need Avogadro's number. I want to come back up here. Do you want moles? You don't. Mole is going to go down here. What do you want? You want molecules. Molecules is going to go on top. You agree? Okay. So molecules goes on top, moles goes on the bottom. So then what I can do, I can cancel out the moles and I can end up with molecules. Now, how do I go from moles to molecules? I use Avogadro's number. And now here's what I need you to really remember. That Avogadro's number is always for 1 mole. 1 mole is 6.02 times 10 to the 23rd molecules. So I need you to remember that Avogadro's number is always for what? For 1 mole. 1 mole is 6.02 times 10 to the 23rd. It's the same thing as before, right? I had 5 dozens. 1 dozen was 12 eggs. So then 12 times 5 was 60 eggs. Exactly the same thing. It's just now compounds and molecules, right? But same concept. Okay, so 1 mole is this many molecules. So if I have 2.545 moles times 6.02 times 23rd, what do I get? You following me so far? So moles cancel out. 1 mole is the Avogadro's number. Now take out your calculator. Today, my focus is you know how to use your calculator. So you have to do 2.45 times 6.02 times 10 to the 23rd and then divide by 1. You don't have to do the divide by 1. Okay. Now, before you tell me what you get, you should also care about significant figures, right? That thing always comes back. So we have to care about significant figures. Now, 2.45 is how many sig fig? This is 3 sig fig. Now, how many sig fig is this? This is exact number. This is not going to count for sig fig because you didn't measure the Avogadro's number, right? This is exact number. This is not going to count my sig fig. Sig fig is for something that we measure. What did we measure? This is what we measure over here, 2.45. So my final answer should have 3 sig fig, which would be 1.47 times 10 to the 24th. I'm having a real hard time reading my handwriting, so hopefully this answer is right. So 1.47 times 10 to the 24th molecules. We're good? Okay, these would be molecules. Any question? I can't ask questions. Sorry, I always feel like I'm in a classroom. We're good? Okay. Again, what we're doing again, we're just canceling out. What we're doing again, we're canceling it out. Ready for the next question. Let's do the next question. Again, have this in front of you. Everything comes back to this. Everything comes back to this. So, the next question I'm doing, how many moles are in how many moles are in 1.81 times 10 to the 24th molecules of ammonia? I haven't really got a chance to talk about ammonia, but I do want to talk about ammonia. Ammonia is NH3. I want you to know that formula for a few reasons. For all the cleaning supplies that you use, I'm not going to say all of it, a lot of them, they have ammonia. And the ones that don't have ammonia, they put on a label that is ammonia free. So it's good to know what ammonia is. Ammonia is NH3. Ammonia is NH3. And ammonia is a weak base. Ammonia is a weak base. Again, you don't really have to know any of this for this lecture, but I really want you to know what ammonia is. Again, so ammonia is NH3 and ammonia is a weak base. Ammonia is NH3 and ammonia is a weak base. We're good? Okay, weak base NH3. So let's go back to the actual problems here. So it says how many moles are in one part. So I want to write down what's given to me, which is 1.81 times 10 to the 24th molecules of ammonia. That's what I have. And ammonia is NH3. Don't forget that ammonia is NH3. Next time when you read the label, it says it has ammonia, it's ammonia free. You go, I know that is. That's a weak base. It's NH3. So 1.81 times 10 to the 24 molecules. But what do I want? I want moles. I want to come back to this beautiful chart. I call it beautiful. You may not. So I am right here. Molecules. I want to get to here. Can I do that? Yeah. I can go from molecules back to moles. What do I need? Avogadro's number. Now here, I don't want molecules. Where does it go? It's going to go on the bottom. You know that, right? They have to be the opposite to be able to cancel out. So molecules goes here. Mole is going to go on top. We're good so far? Okay, so if I do that, then molecules can cancel out on the opposite side and the mole goes on top. So I don't want molecules, I have to cancel it out and the mole goes on top. How do I go from molecules to moles? I use Avogadro's number. Now, what I just told you a minute ago, don't forget, Avogadro's number is always for 1 mole. So 1 mole is 6.02 times 10 to the 23rd molecules. Okay, you want to follow that? Again, I have molecules. I'm trying to go from molecules to moles. To go from molecules to moles, I can do that. I need Avogadro's number. I don't want molecules. It's going to go down here, so I can cancel it out. I want mole on top. Now, what's the conversion here? 1 mole is 6.02 times 10 to the 23rd molecules. So molecules can cancel out. I can end up with moles. Now, the reason I'm doing this problem is because usually people mess up here because of the calculator. Put in your calculator. Now, when you put in the calculator, here's the one thing that people make a mistake. So what you have to do is 1.81 times 10 to the 24th divided by 6.02 times 10 to the 23rd. If you don't put parentheses around 6.02 times 10 to the 23rd, when you put in a calculator, what your calculator does, it divides it by 6.02, but it multiplies it by 10 to the 23rd. Because remember, you have to take this and divide it by this whole number. So you have to put parentheses. If you don't put parentheses, you won't get the right answer. Or the other way to do it, have 1.81 times 10 to the 24th divided by 6.02 and then divided again by 10 to the 23rd. That's like a little bit easier way for me to do it. Or put parentheses around it. But just be careful. This has to be divided by this whole thing. Now, how many sig fig my final answer should have? How many sig fig my final answer should have? My final answer should have 3 sig fig. Because I have 1, 2, 3 here. This is the exact number. So my final answer should have 3 sig fig. You guys agree? Because this is 3 sig fig. This doesn't count. Okay. What I get is 3 sig fig, 3.2 3.01 moles. 3.01 moles. And if you don't get this in your calculator, it's probably because you forgot to put the parentheses. So you divided it and you multiplied instead of dividing this whole thing. Okay, today is like you learning your calculator. So make sure you get this. If you still don't get it, show up to office hours. Yeah? Okay. We have one more practice problem to get all the basics out of the way. Here's our next practice problem. Our next practice problem is, okay. How many moles are in 28 grams? How many moles are in 28 grams of ammonium carbonate? NH4,2CO3. How many moles are in 28 grams of ammonium carbonate? Okay, I'm going to start with what's given to me, which is 28 grams of ammonia carbonate. I'm going to start with what's given to me, which is 28 grams of ammonia carbonate. Okay, now I want to come over here. I have grams. I'm trying to go to moles. So look where you are on this chart. So I have grams, but I'm trying to go to moles. Can I go from grams to moles? I could. I just have to use molecular weight. I'm going to come up here. Do I want grams? I do not want grams. Where does gram go? Gram is going to go down here. Okay? So again, you have to see what you're trying to cancel out. You're trying to cancel out grams. So what's going to happen is gram is going to go down here. I want moles. Mole is going to go up here. We're good so far. This is great because then I can cancel out the grams and I can end up with moles. Now, how do I go from gram to moles? I use molecular weight, right? I use molecular weight. And we said molecular weight is for 1 mole. Molecular weight is always for 1 mole. This is really, really key. Avogadro's is always for 1 mole. Molecular weight is always for 1 mole. I know I'm keep repeating myself. You'll see why. Remember those things. So, now what I need to figure out is the molecular weight of ammonium carbonate. Let's do this one together since this is the first one. So how do I figure out the molecular weight of ammonium carbonate? I have to add up all the molecular weight of the atoms and then add them up together, okay? So how many nitrogen do I have? Remember, you have to multiply this out, right? So ammonium carbonate. So we're trying to figure out the molecular weight of ammonium carbonate. You would have to add up all the molar masses of all the atoms. So how many nitrogen do I have? I have 2 nitrogen. Okay, I have 2 nitrogen. How many hydrogen do I have? I have 8 hydrogen. You guys are following me so far? Okay. Then I have 1 carbon and I have 3 oxygen. Okay. Again, I'm trying to go from gram to moles. To go from gram to moles, I need a molecular weight, right? Gram to mole, I need a molecular weight. So now the compound I have is ammonium carbonate. I need to figure out what is the molecular weight of ammonium carbonate. It has 2 nitrogen, it has 8 hydrogen, 1 carbon, and 3 oxygen. Now, when you look at the periodic table that I gave you, a lot of depending on the periodic table, there is a lot of digits sometimes for the molecular weight, for the molar masses on a periodic table. How many of those digits do you take? Now, here is the rule. People don't usually follow this, but this is the official rule. How many sig fig is this? 2. So your molecular weight should match that. This is 2 sig fig. So your molecular weight should match that. Okay? Not many people follow that, but if you want to follow the rules, that's what it is. So look at the nitrogen. What's the molecular weight of nitrogen? Again, I can just round it to 2 sig fig because that's how good my problem is. I'm as good as just 2 sig fig. So if you look at it on the periodic table, nitrogen is 14. So it would be 12 times 14. It would be 28. Hydrogen has a mass of, it would be 1.0. So mass of 1 is, it would be 8. Carbon has a mass of 12, right? You guys agree so far? So I'll just have one carbon, that would be 12. Oxygen, it's 15.999. Again, I'm going to round it to 2 sig figs. It would be a mass of 16. 16 times 3 is 48. You know what I have to do? I have to add up all these numbers. Okay? If I add up all these numbers, I get 96. So I get 96 grams per mole. That's the molecular weight. So the molecular weight is going to go here, and the molecular weight is 96. The molecular weight is 96. We're good? Okay, I'm going to repeat this one more time to make sure everyone's on the same page. So, trying to go from gram to moles. To go from gram to moles, you need molecular weight, yes? To gram to moles, you need molecular weight. Okay, now I wrote down the gram goes down here so you can cancel out, the moles goes on top, that's what I want. Now, in order to go from gram to moles, I need molecular weight. Molecular weight is always for 1 mole. So I'm going to put 1 mole over here. Molecule is always for 1 mole, and I put the gram here. 1 mole. Now, 1 mole of ammonium carbonate, you have to figure out the molecular weight of the entire thing. It has 2 nitrogen, it has 8 hydrogen, 1 carbon, 3 hydrogen. I figured out all the molar masses from the periodic table, multiplied by how many I have, and then I'm going to add them up together. When I add them up together, I get 96. And again, how many sig figs do you use for the molecular weight? The rule is, here I have 2 sig figs. You agree? Here I have 2 sig figs. And everything should match that sig fig. This is my sig fig of the problem. So the molecular weight should technically match that. So I have 96, also 2 sig figs. So then the grams can cancel out. I can end up with moles. Again, when you do this, again, go with canceling out. I don't want the grams, I want the moles. I don't want the grams, I want the moles. Grams can cancel out, I have the moles. To go from gram to moles, I need molecular weight. Molecular weight is always for 1 mole. So 1 mole would be 96. Okay, so when you put this in your calculator, what do you get? I get 0.29. 0.29 moles is what I get. So far, so good? Okay. Alright, so today was basically to get the concept down and also to go over any calculating errors that you could have to make sure that you're on the same page as me. Nice job today. Again, the next couple lectures we just do nothing but practice problem and get a little harder to, I think you can do it, get a little harder. Now, remember, doesn't matter how hard the problem is, how easy the problem is, go back to this, okay? Have this in front of you every time. Nice job today. I will see you guys next time.